we have this. This is a classic blockchain representation. So there are different blocks here. They're all connected together, and there are different cryptocurrencies behind. I kind of like this logo a lot. I just put it. So let's talk about evolution. Actually, it started in 2008 with the Bitcoin. Blockchain actually started with Bitcoin, and the first block that was mined is called the Genesis block. So wherever you see in the internet, you will find this word called Genesis. Genesis is the first block that was mined, and that was done in 2008 by Satoshi Nakamoto. He's the one who invented he's the one who made blockchain very popular. So blockchain was already there, but it was not very popular, and people didn't know how to use it. So he made it very popular. So after that, in 2012, it became very popular because Bitcoin was traded on the exchange as a cryptocurrency. And I also bought some coins. I ended up buying some coins. And then in 2013, Ethereum had come, and then people started writing smart contracts. Nobody knew what Ethereum was initially, and they also modified Ethereum to make it quicker than Bitcoin. Bitcoin takes a while, so they modified it to make it quicker, and they added basic smart contract capabilities, which is like validating business logic, which Bitcoin will not do actually. Bitcoin does not have smart contracts. Then Ethereum became very popular, and people started building apps on it. And then in 2016, like 3 years, we had fully working smart contracts for financial industries like Wells Fargo, Chase, JP, whatever. The banks are there. And 2018 started the movement of DApps, which is what we're going to build. So we are going to build a DApp for compliance. We have to migrate our app into DApp.
So what's a DApp? What's a DApp?
DApp is decentralized. So I'm just writing it down.
Decentralized.
Decentralized, yeah. I'm going to talk about a lot about decentralized because it is very much different. Dave asked some questions last time. I'm going to answer them today.
Okay. So as long as we get into that, because I want to understand how our system is going to be decentralized, so we can have a true blockchain through Ethereum. Anyway, we'll talk about you're going to explain that. Okay, good.
Yeah, I'm going to walk you through that. So once 2018 went away, right? 2019 was the one when blockchain became very popular, and the currencies there was a big chain of currencies which were launched on the Ethereum network, and CBDC also was launched, which is the central bank digital currency, and also USDC was launched, which is United States digital currency, which I own some. So we are moving away from the traditional paper dollar, and we are moving into this cryptocurrencies here. I just want to make a note that Bitcoin is not a cryptocurrency; it's a crypto asset. So don't get confused by Bitcoin as a cryptocurrency. It's not a cryptocurrency; it is just a crypto asset.
So what is a cryptocurrency then? So if Bitcoin's not a cryptocurrency,
yes, on the next slide I'll tell you.
Oh, okay, all right.
Bitcoin is a crypto asset; it's not a currency. I'll tell you the difference.
Okay, good.
And the next one is tokens. There is also a difference between a token and a coin. Coin versus token. So token is something that runs on a ERC20 standard defined by Ethereum. Okay, that's what a token is. Coin is when you build your own blockchain, when you build a new blockchain, which is actually forked from Ethereum. That is a coin. I'll get to details.
Okay.
So there was this joke on blockchain from the Dilbert comics. So he's the boss. He's got this pointy head. He's called pointy head monster. So this guy talks about blockchain to him, and he says maybe we should do an initial coin offering. And he's like, what is that? So he says he talks about technical terms here. It's a non-equity process for raising capital that uses custom cryptocurrency, okay, and the blockchain. Actually, he's right. This is the right way to describe it. He says, I might be wasting my time here. And he says he understood like this. It's a chain made of coins. So if you don't understand Bitcoin, right, blockchain Bitcoin, it's to get it right for the first time. So you got to stick around and learn.
Okay.
So let's talk about. So there are a lot of jargons here. I'm just trying to introduce you to the jargons, and I'm going to go into details. And this is like a very pictorial slide. It's not just text, so it makes it a little interesting. So there are various components to a blockchain, to a cryptocurrency situation. Right? We have a blockchain. We have verification. We have wallet, which I showed you last time, the MetaMask wallet, and the wallet has an address, and it is secured on the blockchain. That's why there's a lock symbol here. And the cryptocurrency part, you have a mining, and there is some percentage of money that is taken by the miners. And then coming on this, you have the investment part. The ICOs are the vehicles for investing into a blockchain or a crypto project. Then you have the security on the network, and this is hashing. This is actually a block, building a block and hashing. And this is like a trust. You establish trust when you build a blockchain, and there is a transaction and the concept of a smart contract. So everything is covered in this one slide. Okay, any questions?
No.
Okay. This is a technical definition. I really don't want to go in detail into this, but I'm going to walk you through all this in the coming slides. Basically, we are doing a decentralization. We are building a ledger. Ledger is just a bunch of transactions. Since the ledger is actually built by miners, we call it distributed. It's a distributed ledger. So currently, right, the bank, whatever you transact with, right, Bank of America, whatever, they maintain a centralized ledger. That's the main difference. They maintain a centralized ledger. Here we are maintaining a distributed ledger. That's the main difference. And we have data integrity because of the mining, and it is transparent because anybody can look at the ledger. That's the main difference here. So all this together becomes blockchain technology. All this concept together. So let's go a little deeper into this. So there are three kinds of ledgers, as you can see here. There is the centralized ledger, which is the bank, where everybody has to talk to the bank to get things done. There is a decentralized ledger where some portions are stored outside of the network. There are some which are away from the centralized area. They're away. So if this goes down, you will only lose this part of the network. This is still up. But in this case, if the central server goes down, everything is down. So that is decentralized. But distributed is way different. The thing about distributed is, right, every node is independent of each other. Every node is independent. And whenever a transaction happens, it is broadcasted to all the nodes. That is the main difference. And yeah, sorry.
Go ahead. Keep on going.
So I'll explain what a node is. I'm going to explain what a node is. And nodes can come and go whenever they like. I mean, I can switch on a node and switch off a node. It will still hold good. The transaction will still hold good.
So, because you're explaining this decentralized here, how would that relate to this current system we have? Because we have to have you have to have a decentralized database. So how do we do that with this current system we got?
Yeah, so we will have to build a node actually. We have to build our software so that it can run on a node, on an Ethereum node. Right. Then it becomes decentralized. I'll walk you through that. I put up a diagram actually, how the future of implementation would look like. Okay.
Right.
So before we jump into that, right, I want to show you the different kinds of blockchain, okay, so that you understand what we're trying to build. So there are three kinds of blockchains. One is a public, one is a private, and one is in between, consortium, right? Public is very open, which is this one. Bitcoin and Ethereum are public blockchains. Private blockchains are like, I think Hyperledger could be a good example. Multi-chain is a good example of private blockchain. Consortium is what we were trying to use, like Hyperledger. In consortium, you have multiple companies. Like it's like this. So I have a company C1 and I have a company C2. and they want to merge together and then just share the blockchain part of it. So blockchain goes here. Okay. I mean, I wanted to get this very clearly. Okay. So here we control the nodes. So suppose C1 is implant, right? We know what nodes are running, and these guys know what nodes are running. Okay?
So tell me what nodes would be running on compliance right there. Which ones would?
Yeah. So these two. So all the C1 is compliance. So C1 is compliance here. So all these are other nodes. See, all these are other nodes. These are common nodes. This is actually a common blockchain, but these are our nodes here. X.
And what would be an example of our node in our blockchain right here in compliance?
So okay, first of all, we are not building. I don't think we are building a consortium kind of situation. We are building a public blockchain. We won't be building this.
Okay.
So there are problems here. See, I'll give examples. So we have to build something that has no permission. It has to be permissionless, and it has to be impossible to tamper. This can be tampered, and this one needs permission. So building this, I don't know how this is going. So we have to work on that. We have to decide on that.
Can you do me a favor before we decide on this piece right here? Can you just run it by Gordon and see what his input is, just to see if he may have some suggestions?
Yes, absolutely. Yes.
Because he may say some reason why that neither one of us have thought about. So let's just run it by him.
Yes, we'll do that. So those are. So I wanted to understand that there are three kinds of blockchain. There's a public blockchain, there's a private blockchain, and there's in between a consortium blockchain. The main difference is we control. I mean, if you are using a blockchain consortium, we control which companies, which entities, or which organizations use that blockchain. Okay, so that is consortium blockchain, which is actually done by Hyperledger. So Hyperledger was actually started by IBM. They put a lot of money into it actually, and then they open sourced it and they gave it to Linux Foundation. So that's what happened. I don't know how much popular this is, but I know that Ethereum is very popular because of it being a public blockchain, and it's like impossible to tamper, and there's some benefits to it, and it's permissionless also. So here, when I say permission, right, needs permission, it means that whoever is using this node, whoever is looking at these transactions, need to have permission into the system, which is very similar to this. This is an example of a permission-based blockchain. This is the example. So all the blue ones are not anonymous. They need permission to be on the network. That's the main difference here in these two.
And so which one would we be using on that?
This one, we're using the public one.
And when it comes to the nodes, the permission or non-permission, which one would we use?
Permissionless.
Permissionless. Okay, gotcha.
Yeah. Because this is the highest level. It gives you the highest level of security, where it's impossible to tamper. You know what? Why I don't prefer the private in this one, because I'll explain you how we can change the blocks. In case of consortium blockchain, we can actually change the blocks. We can actually tamper the blocks. I'll show you how it can be done.
Okay.
I wanted. You got this, right? You got this. Basic gist of this, right?
I got the public. I got the difference. Permissionless needs permission. I got that. I'm just trying to figure out how to what we're currently doing or what we have done and how to.
Yeah, permission is to allow a node to mine. Permission actually means you are allowing some node here to mine our transactions. That's what permissions mean. Okay,
I need that explained deeper, and I'm sure you're going to get into it to another slide.
Yeah.
I'll let it go.
Yeah. So first of all, let's get clarity on the tokens, guys. I'm telling you, this is very important. So this is not a cryptocurrency. It's just a crypto asset. It is just a store of value. Do not get confused by the YouTube channels and the media. Okay, it's just a crypto asset. Asset is like a home, like a house. You cannot exchange your asset with something else, right? You cannot do it and also the line is very thin, because there are some companies who are accepting Bitcoin as a payment, but still it's an asset. It's not a currency. Okay, so just get this clear. Okay, now this is the most important, the utility token. Ethereum is a token. Token actually means it's ERC20. That is the standard. And ERC means Ethereum request for comment. That's what it stands for. Okay. So ERC is just a standard. There are several of them, and 20 stands for this Ethereum as a utility token. So that's why all the tokens come from Ethereum. All the tokens that you have come from Ethereum, even the carbon token. Now, digital currency is Libra. Okay, this is a good example. Libra is created by Facebook, and they wanted Facebook users to exchange money on their network. I think they changed this name to DM or something. It's not Libra anymore. It's DM as of 2020. So this is a digital currency, and this is a secure token. We can talk about this later. It's not applicable right now. It's just there on the diagram for you to understand.
So let me get this so I can understand this. So we're going to be building a token, not a coin, when it comes to blockchain, and that token. We see all these cryptocurrency and assets and things listed. How would we list this token to raise money, possibly, or to have it as value?
Yeah, so we do an ICO to raise money, and then we put it on exchange. We can put it on an exchange, and it will start trading actually.
So So one of the goals, one of the strategies we got to look at is we want to build this before while we're into the competition, because if we start gaining traction, making the top 15, this token that we're building here could become very valuable just because of what we're doing here with the competition. Correct, Naveen? Am I?
Yes. Yeah. That's
Okay.
right. That's right. Yeah. So Will, as a thing, right? You need to have a big perspective because you're the one who's actually getting it all in, right? You're the one who introduced blockchain to compliance, right?
Correct.
So I just wanted to have a very big picture of what all this take. I mean, how much does it take to get all this together, right?
So one thing I needed clarity on is so nodes in this to stick with this slide is the coin versus a token, or a token versus cryptocurrency versus a coin. What are the differences?
Yeah, the difference is like this, Will. So when we use a token, right, basically the goal is to build a blockchain. That's the goal here, okay? Mm-hmm. So this is a blockchain. It looks like this. I mean, I'm going to go much deeper into this. Okay, blockchain looks like this, right? Now, when you use a token, when you use this ERC20, right, this runs on Ethereum. This whole thing will run on Ethereum.
Got it. Mm-hmm.
Okay?
And those are the blocks.
If you use a coin, we have to build this whole thing, which is much harder. We don't have anything to run this on. We don't have this even. We have to figure out a way to run these on our own.
Okay.
That is the main difference. We might do it eventually. But it's going to take exponential amount of time. And that is the main reason. And token can be used to raise money, and then we can go ahead and build our own coins.
And so we can use a token for ICO.
Yes.
We can use Ethereum's platform already to produce the token, and then eventually we may build a system around the coin.
Yes.
Now, on the token itself, do we have to register with the SEC or either one of these?
Only when you put it on the exchange for trading. Even while doing an ICO, we have to register with SEC.
Okay.
Yes.
Okay.
Yeah.
All right.
It's just like shares. It's like issuing shares in a company, right? Just like that. Okay.
Now, let me ask you a quick question. So we produce this token that's around Hempliance, around this blockchain that we created through Hempliance and our algorithms, and et cetera, et cetera. Should the token itself, should that be part of Hempliance, or should that be its own separate entity?
No, token is part of the Hempliance, yeah.
Okay. All right.
Yeah.
Just curious.
So this is our new. They will be very disappointed. So we have to remove all this, whatever we built so far, and we have to re-architect it like this. So this is our old Hempliance. Okay. We have a user. It can be a mobile user. It can be a web user, laptop, right? And we talk to an application server, and it talks to our database. That's what we're doing, and we're using Azure to host all this. That's what we're doing. Right? That's not going to work for us now. We have to build a node. This is actually a node. This dotted line here, it's a node, and and all the nodes are the same. They look very similar. All the nodes are same. We can have as many nodes as we want. And the miner comes along and he builds this block. He builds this block for us. And so this is the blockchain. This is the EVM in the blockchain. And because it's a node, all the nodes talk to each other automatically. They all broadcast the transactions to each other automatically. So all of them will be the same. And then we use a browser here and the MetaMask to interact with this blockchain and get the data. And these are all the users.
So let's take a step back and go back to the database.
This is how it's going to look like. Right?
So
this is the future. This is the future of compliance. Yeah.
So do we have to take everything out of the database? Is that what you're saying? Or we keep our database, correct?
I can give you a very easy answer, okay? Okay. If you remember right now we are creating a lot. We're creating a lot. We are modifying a lot. We're adding stages to a lot. Remember all that stuff?
Yep.
All that stuff will come as a part of a block.
Okay, good.
Okay. All the stuff that the farmer does, like creating a lot, that is one transaction. I'm going to go into details, Phil. So just wait for that, okay?
Okay.
At least I'm glad that you understood the differences. I think you're seeing the difference here, the work we have to do. Okay.
But question about a miner. So we would have to have actually a miner who does some sort of computation to make a coin.
I'm going to show you how to mine right now. I'm going to show you in this session how to mine. Okay.
Are we going to? Okay, that's. I'm getting ahead of ourselves.
Yeah,
okay, I was going to ask if we.
Yeah.
Okay,
so
keep on going.
This is how our architecture will look like. Okay. I want you to understand this layers very well, okay? Because you have seen bits and pieces of it so far. You've seen what a wallet looks like. You have seen some parts of this. You have seen. So basically, we have to put up a decentralized ledger, and this ledger is a set of transactions. And each transaction is one. Like creating a farm lot is one transaction. Updating a stage in a farm lot is another transaction. So this ledger will have that. So what our ledger is directly proportional to our farm lot database. That's what.
Okay, so that ledger. Let's just stay right here for a second. That ledger is just what our current database is, correct?
No, we are going to move it to a node. We have to move it. You have to build a blockchain out of that ledger. The farm lot database that we have, we have to build a blockchain out of that.
So we have to. So the hashes that we create, those hashes will be part of that. Is that what we're going to be?
That's right. I'll show you. Yes, that's right. Just not the hashes, the whole thing, the whole transaction. Okay. The whole transaction should be part of. So we have one record. Right? We have a document. I think we have a document which has a farm lot and then stages, right?
Yeah.
So, but now each farm lot will be one transaction, and each stage will be another transaction. That is how we're going to break it down, okay? And each we have to hash every. The miners will come and hash every stage and every transaction. I'll show you. I'll just go a little deeper into that.
Okay, so here's what we have to be aware of, because what we're going to be doing is measuring metric tons when it comes to the carbon credit. Okay, so we have a lot. They're going to define that acres. We're going to define. Really, we're going to have a sitemap, so we're going to know what that is. So we'll be able to create some type of conversion rate to get down to each acre and define that acre with how many metric tons within inside that acre. Okay, because that's what we're going to use for the token is that metric ton. So we have to be aware of that. I'm just stating that for the record. Okay.
Yeah.
All right. Does that make sense? Because remember we talked about that the other day, that we're going to use the metric ton for the
that's
measurement.
fine. That's we can do that. Well, let's start.
Okay. All right. Okay. All right. Keep on going. Okay.
So there are two kinds of smart contracts, guys. Okay, one is a token smart contract, and there is an application smart contract. There are two different kinds. Okay, there's a lot of stuff, a lot of details here. I'll go over it later. Okay, and we can store some data in an off-chain app. There's an on-chain and an off-chain. So we can store some data in off-chain apps as well. But we have to store our farm lot, the main thing, on the chain itself, on the blockchain itself. So these are different words that you need to understand. Who is a participant? What is a token? What is a transaction? What's a block structure? I'm going to talk about block structure right now. Okay? What's a validation? What is a consensus? Proof of work is one consensus. There is also proof of stake. I'm going to explain that also. And what is mining and what is a blockchain? And then, so basically every DApp, right? Every DApp has this layer, an application layer, and then a central ledger layer, decentralized ledger layer, and then P2P network. So that's how it is. These are the three components. You understand how we are modifying our existing appliance to fit into this DApp structure. Okay, next is hashing. This is the most important section of this presentation. Okay, the hashing. What's a hash rate? What is a confirmation? What is my?
Naveed, give me just one second. Hold it. This is very important for me to understand.
Most important. So let me go through a small demo. Okay, so first of all, hash is a cryptographic algorithm that is it's a one-way. It's called one-way. One-way means you cannot deconstruct the input from this hash here. Okay, I want you to understand that very clearly. Okay, so you cannot deconstruct your input from this hash. For example, I'm typing will here, right? So I have a new hash here. I cannot take this and deconstruct back to will. I cannot do that.
Yep.
Okay.
Correct.
I want you to understand that very clearly, okay? And the hashes are so secure that if you even change one character, the whole hash will change. So, for example, right, I put a Z here, the entire hash has changed. Okay, so that means I cannot say that, okay, just because having one character here, I can decode will. I mean, I can decode that name. I cannot do that. Okay, first thing, that's the first thing to understand. The second rule is, no matter the amount of data in this box, the size of the hash is always constant. So if I take a big piece of text, okay, take a big piece of text. Suppose I take this big lorem ipsum text, this whole thing. I'll still have the same size of the hash. Oops. It will still be the same. The size is always constant. Okay, those are the two things you have to remember very clearly. Okay, the size of the hash is always same, and you cannot deconstruct this text here from this hash. You cannot deconstruct. It's just never possible. It's just not possible. It is computationally impossible. Okay, that's the first thing you should understand. Okay? The second thing is I'm going to talk about how a block looks like. Let me share this screen. Can you see my whiteboard?
Yeah.
Okay.
Yes.
Okay. I have this contraption, okay, where I can actually draw. Okay. So a blob actually looks like this. Okay, this is a blob. Can you see my drawing? Okay. A block looks like this. Okay, and a block has two parts. One is the header, which looks like this, and one is the body. The body has a bunch of transactions. Just like this. Now the header, right? The most important. The header has. This is called a Merkle tree. Actually, let me. The way the transactions are actually recorded here is called. I'm going to show you. It's called a Merkle tree. So it is stored as a tree structure. It's stored like this. Root. There are two branches, and each branch has two. I know I'm very technical, but you have to understand this. Okay? So here I have four transactions. Okay? X3, X4. Okay. Now this root, this is called the Merkle root. That is actually stored here. The root hash is stored here. Okay. Now.
So let's pause for a second. So I have a great understanding. So
yeah.
there's the hash is up top, so we got the hash. Below is the transaction. Now, give me a sample of what a transaction would be inside of our database or anywhere else. What would that transaction be?
Yeah, let me explain that. Okay, so let me draw a transaction. So every block, right? Every block has a block number. Okay. Just I'm gonna get you into transaction. Every block has a block number. So block 1. Okay. The first block. And the second one is the nonce. This is very important. Okay. What is nonce? Then I'm gonna get into transaction. So nonce. Okay. The third one is the data, which is actually this, which is actually the Merkle tree root. Okay. That's actually here. That's the data here. Okay. Now I'm gonna get to the transactions. So I wanted to understand this very clearly. So a block has two sections. One is the header, and this is the body. Okay. The header has a block number. I'm putting a 1 here. It has a nonce. I'll tell you what nonce is. Okay. And then it has data. Okay. A data is like
that's in a hash, correct?
This data is actually the data will have the Merkle tree. This hash, not the whole thing. This hash. Okay. I'll tell you why. I'll give you the details. Okay. So for now, just remember that this data will have only the Merkle tree root hash, which is this one, and the data is actually here. All the transactions.
Okay.
How does the transaction look like? Okay. It's very simple. The transaction looks like this. So I'll have a transaction ID, like 100. I'll have a farm lot ID. It's been a while. I got rusty on. I'll have a farm lot ID. I'll have a stage ID.
Okay.
And then the guy,
everything right now.
And then the user who created this, the farmer user ID. What is that user ID? What the?
Just put user ID. That's fine. We'll
understand. And then the date. Date time.
Timestamp.
Timestamp. Yeah.
I got it.
Okay. But the thing is, what I wanted to know is, right? If a farmer adds a new stage, then you'll get a new role. That's a different record. Okay.
Because the stage ID.
This transaction is only for the first time a farmer creates a lot. Okay, and there are no stages in it, right? Remember, Dave? I'm not really current on it, but yeah.
So that would be the farm lot, and then the one below that would be stage ID, date, and none of those would be consistent because the stage ID would change and the date and time would stay.
That's fine. That's absolutely fine. That's fine. As long as it belongs to the same farm lot ID, we are good. As long as these two match.
Keep on going.
Okay. Now that's how a block looks like. Okay. Now I'm going to talk about the most important one, is a nonce. Okay. This is where binding comes. So what is nonce? Okay. Why is it named called nonce? N-O-N-C. Okay. I don't know why this guy. Nonce means number hyphen once. A number that is used only once is called nonce. This is the core. I'll tell you why this happens. And now I'm going to show you the mining part of it. Okay. You understood this, right? So this number, there's a number you have to put here inside this. A miner comes and puts a number here. Okay. It's just a number. It's like 1, 2, any number. It's just one number. Okay. But this number is not. But this number will not be. The number will not be reused again ever for this block.
Okay. How many characters is it? 31 characters?
It can go up to like 100 million. This number. The number can be like 100 million. Yeah,
and it's a unique. Million, it's a primary key basically. So
it's not a primary key. No, it's not a primary key. It's a nonce. I'll tell you why it is used. Okay. It's not that hard.
Okay.
Okay. Then you go back to the other. You understood, right? No, I want you to understand this at a high level. If you have a block, you have a header and a footer. Header and a body. Oh. Header has a block ID, as a nonce, and it has data. Data is a Merkle tree, which looks like this. I wanted to make it very illustrative, so I'm using this dashboard. Okay. A Merkle tree looks like this, which has leaves here. The most important thing to remember is this is always even. You will always have an even number of transactions here. Okay. In a Merkle tree, there's always 4 or 6 or 8 or whatever. It's always even. Okay. If it is odd, right? In case if it's odd, what it does is it copies this last transaction here again. I don't want you to get into details, but I just remember that it's always even. Okay? Just for now.
Got it.
Okay.
I got it. So, yeah.
So that's it. That's all. This is not very hard. And the transaction looks like this. There is no limit on the number of transactions. There's no limit. Okay. You can have as many as you want to. You have to pay more. Maybe you have to pay more money. That's the difference. Okay. Yeah. Let's go back to the nonce part of it now. Okay.
Okay. Now, one thing I don't have clarity on, the bottom part transaction. What was that?
I'll show you. So, can you see my screen now?
Yeah.
Okay. So when the miners come, right? So the goal of a miner, right, is to put transactions into a block. That's all they do. Okay. So right now, who does that job? The database does the job for us. Remember, right now with the appliance app that we have, the database does the job for us. Database comes and it puts transactions for us together into a database, right? That's the difference. The only thing is the miners will do it for us. The miners will mine it. Now, what is mining? That's the question. What is mining? Mining means this hash, right? This hash here, if you look at this hash, it starts with 4 zeros. It starts with 4 zeros, right? That is the goal, actually. This is called difficulty. So let me enable export mode here. Now, the block difficulty is 4. Okay, I can go up to 10. I mean, it's got done automatically. This is all Bitcoin stuff. Okay? The block is very specific to Bitcoin. We can have a different block. See you guys in the next session.